Hello, this is an A-level maths video. This is on Pure Mathematics Year 1, and we're going to look at Chapter 1, Algebraic Expressions, the first section, Section 1.1, which is all to do with index laws. Now, if you're starting an A-level maths course, these are rules that you should be very familiar with already. But before we get into it, let's give ourselves a bit of vocabulary here, some terminology that we may find useful. So if we have a relationship like a to the power b there, a to the b, the number a is known as the base, and the number b has lots of different names, actually all mean the same thing. We sometimes use the word power or index or exponent to represent that number. If we had lots of these things, we might say powers or indices or exponents. So let's look at a quick example of what we're talking about here. If we had, for example, an expression like 5 to the power 3 here, obviously that becomes 125, but the number 5 here we would say is the base. And then the number 3 here we would say is the power or the index, or possibly we could use the word exponents there. Okay, got that? Now, as I've said already, if you are starting an A-level maths course, then you should already be familiar with some of these laws of indices, or laws of powers, or laws of exponents, if you like. I've put some on the screen there, and this video is really not going to talk about where they come from. What we're going to do in this video is really just make sure that we can use those rules and remember what those rules are. So let's have a go at a question. On the screen there I've put a question, and I'm just going to ask you to have a go at it. I'm going to leave the formula, those rules up there, those laws of indices, so you can refer to them as you have a go at it. Pause the video, write down your answer, make sure that you've got an answer before you continue the video, please. Okay, how did you get on here? Let's quickly go through this one together. So the first bit of that expression we've got to simplify there was x cubed and all raised to the power 4 here. Now, if we look at the third rule down, we will see that when we have expressions of this form, the powers here get multiplied together. So that will simplify to become x to the power 3 times 4, which is, of course, x to the power 12. So what we're going to do is we'll take that x to the power 12 and we'll multiply it by the 3x squared that we've also got in this expression. Now, the first rule that we can see on the screen there allows us to take the x to the 12 here and multiply it with the x to the power 2 here, and we know those powers get added together when those x terms with the same base get multiplied. We've also got a 3 here as well. You might be thinking to yourself, well, why is the 3, why aren't we involving the 3? Well, of course, what we have here with 3x squared is really just 3 multiplied by, 3 multiplied by x squared here. And so therefore, really, all this becomes is x to the power 12 multiplied by 3 multiplied by x squared. We can combine these two x terms together, and we end up with 3 lots of x to the power 12 plus 2, which is, of course, 3 to the power of, sorry, let me say that again, 3x to the power of 14. Okay, so hopefully you got on okay with that one. Let's have a look at this one here, which is now on the screen. Try and work out how this one works, and we'll check the answer very shortly. Okay, so let's see how we got on with this one. We've got here 3ab cubed, all being squared here, and if we look at our rules, we can look at the last of those 4 rules there, and we can kind of adapt that slightly. So if we have a bunch of terms all being raised to a particular power, then those individual terms can be raised to the same power. So in this particular case, this is going to become 3 squared multiplied by a squared multiplied by b cubed, all being squared, and if we simplify that, 3 squared becomes 9, a squared is still just a squared, And then the b cubed squared, remember that third rule down says we can multiply those two powers together, so we end up with b to the power 6. Okay, let's keep going with this. This one I think is a little bit more complicated, but let's see how you get on. Pause the video and restart it once you've got your answer. Okay, let's see how this one works together then. So here we've got some brackets to expand. So we'll have our 3t squared times 2 minus t. And then we're going to subtract t times t minus t cubed we've got here. Okay, all right, so let's expand these brackets. The 3t squared times 2, well, the 3 and the 2 are going to multiply together to make a 6. So we end up with 6t squared there. The 3t squared times the negative t, well, if we multiply the t squared by a t, we get t cubed. So this whole thing becomes minus 3t cubed. Okay, now I'm going to have to be super careful with the minuses that are around on the next bit. So let's just make sure we get that right. The t times the t is going to give us t squared, but if we have that minus there, it becomes minus t squared. And then finally, the t times the t cubed becomes a t to the power 4. But if we have a minus here and a minus here, well, those are going to combine together to make a plus. So we're going to have plus t to the power 4 here. Now I can see a way of simplifying this, because I can see we've got a t squared term here and another t squared term here, so those two can combine together, and we're going to end up with our final answer. 6t squared minus the t squared there becomes 5t squared. Then we've got minus 3t cubed plus t to the power 4. Okay, how are we doing here? Hopefully we're doing well. The last one we're going to do in this video is one which is going to involve a fraction here, an algebraic fraction. Let's see if we can simplify this using our laws of indices there. So how did you get on with this one? Let's see if we can quickly work through the answer here together. So we've got 4x to the 5 plus x cubed, which is all being divided by 2x squared here. We've been asked to simplify this, and the first thing I think we need to do is just recognize that with an algebraic fraction like this, we can split up we can split it into two separate fractions with the same denominator. So let me show you what I mean here. Okay, so we should recognize that that's how fractions work. When we are adding fractions together, if we have the same denominator, then that denominator just carries through, and so we're just kind of doing that in reverse here. Okay, let's see if we can look at each of these fractions separately and simplify it down. Well, looking at what we've got here, the 4 divides by the 2 to make us a 2, and then the x to the 5 divided by x squared, well, that's actually going to be our second rule, isn't it? Where we have the same base here, in this case x, these powers are going to be subtracted here. So we're going to have x to the power of 5 minus 2 here. And that, of course, is going to simplify to 2 times x cubed. But, of course, we've got this other fraction here we also have to deal with. Let's see if we can deal with that. So what we have here is we have, well, we haven't really written it, but in fact there is a 1 there, isn't there? We can think of the x cubed as 1 times x cubed. So in terms of the numbers here, the 1 divided by 2 is going to give us a half. And then the x cubed divided by the x squared, well, we can use our second rule there with our laws of indices. So we're going to have 3 minus 2 here. And then finally, of course, we can simplify that down to make x to the power 1, or just, of course, x. So we've reached the end of this video. Hopefully that was a good workout with those laws of indices there for you, reminding you of what they are, and maybe having a look at some slightly more complicated situations than you may have done before. If you feel like there was anything confusing there, or you need a bit more practice, then exercise 1A in the textbook is where to go for your practice questions. But from this video, that's it for now, and I'll see you again soon.